Hello everyone, I'm Prakalp from NuevoTech Mining. In this video, we're going to look at how smarter algorithms, not bigger machines, are reshaping mine planning. I'll share my experience as a mining engineer and show how the new tools we're developing are revolutionizing planning, scheduling, and decision making. Whether you're in operations, geology, planning, or finance, this session will give you a glimpse of what's possible when intelligent algorithms meet human expertise. I'd like to start with a provocative question. What if the future of mining wasn't about bigger machines, but smarter algorithms? For decades, we've improved productivity by scaling up equipment and pushing harder, but today, we're on the cusp of a revolution. Advanced planning is moving beyond simply optimizing today's operations to actually predicting tomorrow's challenges. Instead of iterating manually through pit shells and schedules, we now have the ability to evaluate thousands of alternatives and arrive at a practical plan in minutes. This mindset shift, from brute force to intelligent foresight, is at the heart of the transformation we're discussing. Traditionally, mine planning meant manual pit optimization followed by a separate scheduling step. We'd iterate for days or weeks, chasing a practical solution that met all constraints. Modern algorithms have changed that. Tools like the pseudoflow algorithm and direct block scheduling explore alternatives rapidly, so we can go from hours or days of design time to just minutes. In our own projects, we've seen execution times drop by 70% and net present value gains of 525%, worth hundreds of millions of dollars. That's not a pipe dream, it's happening now in mines around the world. At the center of this change are two core techniques. The pseudoflow algorithm quickly generates nested pit shells and phase options. It's like having a hyper-fast engineer who never gets tired, iterating through millions of combinations until it finds a near optimal solution. Parametric and generative design then take those shells and automatically propagate changes through complex rules. That means if you tweak a ramp gradient or adjust a bench width, the entire design updates instantly, exploring new scenarios without manual redrawing. Together, these tools unlock creativity and speed we simply didn't have before. But what truly excites me is how these techniques integrate into a cohesive workflow. We start with optimization to generate pit shells and schedules. We then phase the ore body into practical geometries and design those phases parametrically. Because everything sits in a cloud based environment, our teams can collaborate across disciplines and geographies seamlessly. The busy scheduling engine allows rapid scenario testing, and risk analysis is built in. Rather than handing files back and forth between different software packages, we iterate in one environment, making planning more efficient and less error prone. Another leap forward is the adoption of digital twins and artificial intelligence. A digital twin is a live digital replica of your equipment, processes, and environment. By integrating IoT sensors, we get real time data on haul trucks, shovels, and processing plants. AI models analyze patterns that point to potential breakdowns or safety issues. The result is continuous monitoring and predictive maintenance that helps us avoid unplanned downtime. Beyond maintenance, digital twins and analytics can optimize blasting, drilling, energy usage, and even ESG performance. Around the world, leading iron ore and copper mines are using digital replicas of conveyors and crushers to detect wear before it becomes a problem. This technology, combined with advanced planning, gives us unprecedented situational awareness. Even the best plan is only as good as its resilience. That's why risk and uncertainty analysis are vital. We run Monte Carlo simulations to sample hundreds of price, grade, and geotechnical scenarios. Design of experiments lets us systematically explore parameter spaces, while sensitivity analyses identify the drivers of value and risk. Ultimately, we build robust strategies that deliver confidence under changing conditions. In one project I worked on, sensitivity analysis revealed that haulage constraints, not metal price volatility, were the main driver of NPV. By focusing on road design and fleet allocation, we increased value without taking on unnecessary risk. Modern planning isn't just about profits. We embed environmental, social, and governance metrics directly into our algorithms. Plans are optimized for slope stability, water management, and community impact, as well as cash flow. Reducing deviations between plan and reality means our operations run smoother and safer. Cloud based platforms foster collaboration among engineers, environmental scientists, and communities. Importantly, algorithms now include backfilling and rehabilitation logic, so we can restore land as we mine. I've seen mines in Canada and Scandinavia use these tools to design end of mine landforms that support biodiversity while meeting economic goals. The software we use at NuevoTech, MineOpt, embodies these ideas. PitOpt generates nested pit shells using the pseudoflow algorithm, complete with 3D visualizers and graphs. AutoDesign automates pit design from shells and exports results directly to CADI formats. SchedOpt optimizes mining, dumping, and haulage using a mixed integer linear programming approach that maximizes NPV. The stochastic module analyzes uncertainty to locate the hill of value, helping you understand where risk and reward trade off. What's powerful is how these modules connect. Inputs from PitOpt flow into AutoDesign into SchedOpt and the stochastic engine, maintaining data integrity throughout. What differentiates MineOpt from traditional mine planning packages is its seamless workflow. You can run modules together or independently, depending on your needs. The pseudoflow and MLP scheduling engines optimize pit shells, mining, dumping, and haulage simultaneously. Built in shortest path, algorithms choose realistic haulage routes and incorporate backfilling into the plan. The software is interoperable. You can import from and export to other industry tools, but you don't need to constantly switch back and forth. Finally, it emphasizes land rehabilitation. It doesn't just stop at extraction but provides tools to plan your restoration. These features mean MineOpt often delivers better outcomes faster because everything is integrated and data doesn't get lost in translation. To illustrate the impact, let me share a real case. In a 20-period project with 2 million blocks, our algorithms delivered phase optimization in about 5 minutes, scheduling in under 10 minutes, designs with ramps in roughly 30 minutes, and design updates in less than a minute. Overall execution was reduced by 70%, and the project achieved NPV increases of 525%, which translated into hundreds of millions of dollars. The team could run several what-if scenarios, including price changes and haulage constraints, before breakfast. Stories like this aren't isolated. Similar improvements are being achieved in open pit and underground mines worldwide. To wrap up, smarter algorithms amplify human expertise. Digital twins, advanced optimization, and integrated planning are transforming mining. The role of the engineer is evolving from crunching numbers to interpreting results, developing strategies, and incorporating ESG considerations. I invite you to join the new era of mining, unlock greater efficiency, sustainability, and profitability. If you're ready to explore further, visit nuevotechmining.com.au or reach out to us. Together, we can design the mines of the future.